extension off of the lesson we talked about on Tuesday. Thank you. So today's lesson is not going to be much different than Tuesday's lesson. All that's going to be different is that you guys are now going to be graphing two inequalities on one line, or in one graph, instead of one. So you're still going to have to worry about if the line should be dotted or solid, or I should say dashed or solid. You're still going to have to worry about the shading, but now we're going to be looking for the solution to the system of inequalities. So think about it. What do you think the solution to a system of inequalities is if we're graphing two inequalities on the graph and we're shading both? Yeah, Kennedy. What? So part of it is where the lines intersect sometimes, but where else, what other things, what else is intersecting then, too? Yeah, the shaded region is that intersects, so your two colors that you have, or whatever you want to do, lighter or darker, that region is your solution. So that's kind of what we're looking at today to see is where does that at, and then when we get there, we kind of shade it a little bit darker to show that that's our solution. So, we know, what is the system of equations? Tell me what the answer to that is. Hannah, what's a system of equation? Two or more equations, right? So we know the system of equations is two or more equations. So if you have to write your own system of equations, which I ask you to do sometimes, you need two or more equations. And they all both have the same solution. In a system of equations, how is the answer represented and what does the answer mean? In an actual system, how do you write your solution and what does your answer mean? Joe?
Don't you write it in an ordered pair?
It's an ordered pair, so what does it mean?
The x value and the y value?
So the ordered pair is the x value and y value. What about the two lines? What does that ordered pair mean with the two lines?
Where they
Yes, ordered pair where the lines intersect. What are the methods you've learned for solving systems of equations? Alexis, what are the three different ways we've learned how to solve? Not standard. It does start with an S, though. Substitution is one. Let's try another one. Iris, what's another way you can solve? Elimination. What is the last way, Jacob, we can solve that I've taught you? Graphing. So today we will graph a system of inequalities. How will it be similar or different from the system of equations? So similar is you're going to have more than one, line graphed on there. Different is you're going to have shading, dashed or solid lines. So that's how it's a little different is we have to actually shade and do dashed or solid lines. So that's a little different from equations because in equations you never shade. It's just the line is your solution. Whereas in inequality, the line may not even be your solution. It might just be everything above it or below it. And then how will the answer be represented? It's where the shaded regions overlap. Let's say that. All right. So go ahead and get that copied down. And when you're ready, you can flip. All right. So let's graph these. Are they already in slope-intercept form? So we're good there. So I'm going to graph this one first. Then I'm boxing in red. I would still plot, what I would do is I would still plot your lines with a pencil and do the shading with a different color, just because if you make a mistake with your graph, at least you can erase your line and go back with it that way. All right. So, Vivian, help me graph y is greater than x minus 4. What do I do? Okay, then what do I do? Good. Will I have a dashed or solid line, Vivian?
Is this what we do in colors?
So I would draw the lines. No, I would draw the lines with your pencils. It's the shading I would do in different colors, okay? It's okay if you don't. That's just my suggestion. And I'm not like going to mark you wrong if you don't do that. It's just easier if you make mistakes to... Okay, so Vivian, let's continue on with this because there's also shading involved. It says y is greater than x minus 4. Do you think you're going to shade above or below this line? You're thinking we're going to shade above. So 0, 0 is in that above region. So I'm going to check the point 0, 0. Seems like we are going to shade above. Let's see if that's right. And if it's true, we are good. Is 0 greater than negative 4? Yeah, so we're right with shading above. So I'm going to take my different color now and shade above the line. Make it light. I wouldn't shade too dark. All right, the other one is already in slope-intercept form, Morgan. How would I graph that?
1, 2, 2.
Okay, then what?
And up 2 over 1 to the left.
Up 2 over 1 to left, make it a negative slope. Very good. Morgan, will my line be solid or dotted?
Solid.
Okay, Morgan, it says y is less than or equal to negative 2x plus 2. So less than or equal to. Do you think you're going to shade above or below the line? If it's less than or equal to.
Yeah.
So what's a point below this line? Because this is below, right? So what's a point below that line that we could use as the test point? Negative 2 is a, well, that's not negative 2, negative 2. Negative 2 is down here, is a point below the line. So let's try that. So that's negative 2 is less than or equal to negative 2 times negative 2 plus 2. So 4 plus 2. So is negative 2 less than or equal to 6? So is Morgan okay with choosing that point? Was she correct? So since she's correct, we shade that side. If it was false, we would shade the other side. So the answer is your overlapping region. So now what you're going to do here, and you have to do this or else you're not going to get the point. What'd you say?
I did yellow and didn't pink, so there's 3 different colors.
That's good. It changed to orange. Your overlapping region changed to orange. That's perfect. Anyways, so what you're going to do is you're going to take your pencil or whatever you want to take from there and make the overlapping region darker. And just make that region darker because that is your actual solution. So the darkest region is your solution. Hannah used colors that, when mixed, make orange, so hers showed that already. But really show what it is by shading it darker. So anything within that shaded region is a solution to your system. So a solution, give me just one of the solutions, Sarah Muncie. Huh? You're fine. You can see through the black that's there. So what's a solution that's in this dark region? -2, -2 is a solution to this system of inequalities. That's just one of the infinitely many solutions that are involved. So make sure this is really, this part is what's overlapping here. So make sure like you take your pencil and shade that part dark. Kind of like what Iris just did. That looks good. Let me see if yours is shaded dark. So make sure once you get to that overlapping region. So make sure this region is shaded dark, okay? Make sure your region is shaded dark, okay, with your pencil. Okay, I can tell it's darker. Make that a little bit darker, maybe with a different color. So like you haven't used blue, so maybe put blue in there. Maybe even, it is a 5-year-old's project, it's all good. Do you use your pencil just so I can, just go back with your pencil just so I can tell that you really do understand that that's the solution. Why didn't you write anything down? Come on, you need to be doing stuff. For you, because you're using your pencil, circle it, just so I can see that you understand where the region is. Can I see what you have there? You did make it darker, you used like the red a little bit darker, right? Okay. Can you use your pencil to show me? Good, okay. Next one! Alright, x is greater than -2. So let's start with that one there. Jacqueline, how would I graph x is greater than -2? It is a vertical line. Very good. And where do I start at? On which axis? Good. Will my line be solid or dotted? I'll go back and fix mine in a second. All right, it's greater than -2, Jacqueline. So do you think you're going to shade on the left or on the right? So are the numbers on the right getting bigger? So it does make sense that that would probably be where it is. So choose a test point to the right then, Jacqueline. 3, 2, good, is a test point to the right. So if I choose the point 3, 2, is 3 greater than -2, Jacqueline? Yeah, so you chose the right side, so we can shade that side. So take a color and shade that side. Just, coloring everywhere now. Since we're scribbling today, this looks like what my daughter does when I give her something to color with her paint with. Scribbles everywhere. All right. Spencer, the second one isn't in slope-intercept form, so how can I get it into slope-intercept form? You do know how to get it into slope-intercept form. Don't do that. You're solving for y. How do you solve for y? What is not letting y be alone? X. So how do you move the x over? There you go. Spencer, will my line be dashed or solid in this case? Which one will it be, Spencer? Look at this one. This one was dashed. So what do you think this one's going to be? Solid. If it's or equal to, it's a solid line. Okay, Spencer. It's less than or equal to. So do you think you're going to shade below or above the line if it's less than? Below. So give me a point below this line that we can test. Did you say -3, -2? -3, -3? Yep, that's below the line, so we can do that. So I get -3 is less than or equal to negative times a -3 plus 3. So 3 plus 3. Is -3 less than or equal to 6, Spencer? Is that smaller than 6? Yeah, so you just did a good job there. So we can shade now. So they overlap down here in this region here. So that region there is the region we will shade darker. I'm not going to use black this time. That did not go well. So Kelly Kavanaugh, what is a solution to this system of inequalities? 0, 0 is in the overlapping shaded region, so that is definitely a solution. Neither of our test points happen to be solutions, right? They're outside of our overlapping. They worked for the 2 equations we chose, but not for the overlapping. Go ahead and get that done. We'll do one more example, and then we'll do the word problem.
What was the solution of your
Anything in the darker shaded region, so you can choose anything in here.
I would just
Yeah, in there. Make sure it's darker shaded. Yeah, you can. And just make sure that's darker shaded with your pencil. Look at you. Using the colors that make great colors there. So again, make sure you're shading it darker where it's at. Okay, let me see which one I want to do next. Okay, go to the very back page. We're going to go to the very back page. I think this is getting a little redundant anyway, so I think if we do 3 examples, do you guys feel like you'll be fine? Are you okay? Okay. If you guys need me to do more, please let me know and I'll go back and do more. Alright, so this first one here is not in slope-intercept form. So Alex, how do I get this into slope-intercept form? Okay, so I get negative y is less than negative x minus 1. Then what? What do you have to do if you divide by negative? Okay, so we graph that. Alex, will my line be dashed or solid? It will be dashed. Very good. Okay, Alex, since it's greater than, do you think you're going to shade above or below this line? Above. So what's a point in the above region that you think you would work? 4, 4. is below it. You said above. Do you see how that's, do you understand why that's below?
Yeah.
Okay. 6, that's still below it.
Oh, 2, 6.
There you go. So I do 2, or not 2, sorry. 6 is greater than 2 plus 1. Is 6 greater than 3, Alex?
Yeah.
So that's true, so he chose the right side of that. So we just... Katie, help me get the second equation into slope-intercept form.
Subtract the x from both sides, and then divide by -2.
When you divide by the -2, what do you have to do?
Flip the inequality.
Flip the inequality. Very good. So y is less than, negative and a negative is a positive. That's not positive 2x though, that would be 1 over 2x. Negative, or a positive and a negative is a negative. And will my line be dashed or solid? Katie? It will be dashed. Very good. Okay, Katie, it says it's less than 1/2 x minus 2. So what is a point, what point do you think is less than that line? 0, -3 is below that line, so probably. So we'll do the test point 0, -3. So I go back to the original. I guess you technically don't have to go back to the original, but if you want to, you can. So is 6 greater than 4, Katie?
Yes.
So we're good there. We'll shade there. So I didn't shade very well, but where do they actually overlap then? What'd you say? Like in that really little sliver, right? That really tiny sliver. So that's where they overlap, is the really, really tiny sliver. Down here. So I think the point -10, -8 is a solution in that region. It looks like it. -10, -8. Okay. So the last thing we're going to do is the word problem, and I'll just kind of talk through it real quick, and then we will get started. So just make sure you shade your region darker, and then we'll get started with that word problem, and then I'll get you guys your homework out. This is the last lesson before your test. Your test is Tuesday. We'll review tomorrow and Friday, or tomorrow is Friday, tomorrow and Monday, and then your test will be Tuesday. That's kind of what it's looking like. So make sure you're shading darker. The big deal is make sure you shade darker the region where they overlap, so I know that you understand where your solution is. Does that make sense? Otherwise, I can't read your mind. I don't know if you understand. So make sure you're doing that. Yeah.
What is this?
We're going to do that.
Oh, we're gonna do it.
Okay. Lewis receives a $25 gift card to an online retailer that sells digital music and games. Each song cost is $1 and each game is $2. He wants to buy at least 15 games with his card. Okay, so let's go through this here. We're going to have to scale this and everything. So, that was way too thick. Sorry. So I'm going to make the axis here, so make sure you guys make your axis on that line. So we know exactly where it is. Because we're not going to go below 0 and we're not going to go above 0 because, or we're not going to go below 0 on the x or the y because that would imply negative numbers in a contextual situation, which really does not make sense. All right, so from there, he wants to buy at least 15 items with his gift card. So he has, we'll call them X and Y just so we know which one is which. So we have songs and games. So if he wants to buy at least 15, that means he wants 15 items or at least. So at least, if I want at least $20 in my pocket, do I want less than $20 in my pocket? No, it's least is kind of confusing because it seems like it would be the other way around. So we want greater than or equal to 15 items. So the X plus the Y has to be greater than or equal to 15. But he can't spend more than $25, right? Because that's all his gift card allows for. So he has to spend less than or equal to $25. And it's $1 for a song and $2 per game, right? Is that what it says? Yes. So it looks similar to our system of equations, but we have inequalities here. So I'm going to do this by intercepts real quick. Actually, we can just put them in slope-intercept form. That's fine. So we subtract x on both sides. So this would be y is greater than or equal to negative x plus 15. And this one is going to give us a decimal here, but it'll be negative 1/2 x plus 12.5. You guys agree that that's 12.5? 25 divided by 2 is 12.5? It's easier to plot that. Do it that way. So our x-axis is the number of songs, and our y-axis is the number of games. We can count by 1 if we want to here. So this is 1, 2, 3, 4, 5, and then I'm going to start not counting everything. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm going to do the same thing down here. I'm just skip every other though so I don't have to write so many things. Okay, so then I'm just going to plot my lines. So you plot your lines the same way. So I start at 15 and I go down 1 over 1. And I can put it, connect it with a solid line, so I will connect with a solid line. So since it's greater than or equal to, I'm going to shade above that line. So greater than or equal to is above, so I'm going to shade above the line. I'll get that one graphed. The other one starts at 12.5, just halfway in between. Then we go down 1 over 2. down 1 over 2, down 1 over 2. Again, when we go to connect these, we'll use a solid line. And since it is less than or equal to, we're going to shade below this one. So you'll notice the overlapping region is there. Sorry, I'm going so fast, the bell's going to ring soon. So this right here is your overlapping region. So when we're talking about a solution to this, it has to be anything in that overlapping region. So a solution is anything in that overlapping region. So 14, 2 is a solution. Sorry again that I'm going so fast. So 14, 2 is a solution. So he can buy 14 songs and 2 games is the solution. All right, let me get